Okay, so on this video, I'm going to work with problem E and probably do the multiple choice. On your test, Hamilton's and Lowndes will be the same problem. Then I'll actually change the scenario for Webster's and Jefferson's. Okay, now Webster's and Jefferson's might be on the same table or they might be on different tables, but they'll be the same problem. If I put them on different tables, it's just to give you more room. So if I put them on different tables, don't recalculate the standard quotas, just copy them down. So for A, it's 10.979. For B, it's 15.524. For D, it's 12.072. And for E, it's 8.892. Now, remember, when you move to Jefferson's, it will be a new table. You'll have to calculate these again, but you won't have to calculate these again for Webster's, all right? Keep in mind, the standard divisor is still 201.3. That's important in terms of Jefferson's method. All right, so if you think you know how to go about Jefferson's method, go ahead and pause the video. And when you think you've apportioned by Jefferson's method, put your answer here. So on the test, I will actually have you put your answer for Jefferson's off the table. I think it's possible. It depends on if I put them on two tables or one, but but before you actually apportion for Jefferson's method, find B's threshold divisor. So on the test, that's exactly what I'm going to do. Before I actually have you apportion by Jefferson's method, I'm going to say, hey, find such and such threshold divisor. All right, so go ahead and pause the video if you think you know what you're doing. If you're like, I don't remember a threshold divisor at all. So think about it. This is your big hint, the threshold divisor. I am pointing you toward a working divisor for Jefferson's method. So B's threshold divisor is its population, which is 3125, over its upper quota. So what's its upper quota? So it's always population over the upper quota for Jefferson's method. And what's this column for anyway? Well, Jefferson's, like the other two, focuses on the lower quota. So this column is for the lower quota. And once I have the lower quota written in, for B, I can see that the upper quota would be 16, right? You know, it's just easy. And so the threshold divisor is 195.3 for B. Okay. I'm trying to help you out by giving you this threshold divisor. Now, Jefferson's given everyone their lower quota, sort of. What he's not going to then go through and hand somebody an extra seat. He wants to be able to give everyone their lower quota, every hotel. Well, if you use the standard quotas and you give everyone their lower quota, you only hand out 77 staff members. That won't be enough. So what Jefferson says is, you know what? Let's change these numbers. Let's modify the quota. And how did we get these quotas? We got them by dividing by 201.3, the standard divisor. So let's divide them by another number. And I want the answers to be bigger so that when I round, some of these numbers are bigger so that when I total, I get 80. So for Jefferson's method, the modified divisor is always smaller than the standard divisor. You're always going to go down from that, but how far down? Well, when I give you the threshold divisor to find, I am giving you an idea of how far down. So I think your best guess is either exactly what the threshold divisor turns out to be, or something very close, like drop the 0.3 if you want. So I think on the written key I dropped the 0.3, but I think for the video I'm just going to use 195.3. So I'm really telling you what threshold divisor to try when I give you the threshold divisor to find, what modified divisor to try. So I'm going to take, I'm going to show it in the calculator. I am going to take A's population, which is 2210, and instead of dividing by the standard divisor, I'm going to divide by the modified divisor, 195.3. And this will be the modified quota. So 11.3. And then here's the hard part. I did not have space for this, but there'll be a little space for you to say, well, what's that lower quota? That's 11. So remember, you're not going to cut up people. So Jefferson would round everybody down. So he'd round A to 11. Notice we gained a staff member, okay? So do the same thing for B. Take B's population, 3125, divided by, we're trying 195.3, 195.3, and that is 16.0001. Now, are we surprised? Remember, we found B's threshold divisor. This is the divisor that you can use so that B's modified quota would turn out to be 16. Now, it's not exactly 16 because I rounded this number a little bit, but this still rounds down to 16. Okay, don't have enough space there. All right, so finish this and round all the lower quotas and see if you get 80. All right, so I'm going to go ahead and fill these in. I'm going to take C's population, divide by the modified divisor, and I am going to get 33.5. Oh, so I do some blue. And Jefferson's going to round that to 33. I get D's population, divide by 195.3, I get 12.4. Notice with Jefferson's, you don't need really more than 1 decimal. 12.4, 12.41, 12.42, doesn't matter. That's going to round down to 12. And then for E's population divided by 195.3 is, oh, I can't read my writing. I think 9.2, I think. I cannot read my writing, but that rounds down to 9. Now, you're not necessarily done. Add these up. If you hand out this many staff members to each hotel, how many have you handed out? 81. That's too many. So this modified divisor didn't work. It actually made the numbers too big. We need to lose a seat. But we're right on the threshold of losing a seat. Look at this. As soon as B's modified quota drops down to like 15.99, that's going to round down to 15. And so there we'd have 80 seats. And we don't want any of these others to budge. So to make this answer smaller, I have to guess a hair bigger, okay? So I'm going to just try 195.5, and I'm going to put the lower quotas here so we have more room. And if you wanted, you could test this out. Let's start with B, okay? Take B's population, 3125, and divide by 195.5. 15.98. I don't know if you can see that or not. 15.98. Because we divided by a bigger number, our answer was just a hair smaller, and that's all we needed. That lower quota is 15. And then we hope that none of these others drop below their whole number. So we need to go and check to make sure. So take A's population, divide by 195.5, etc. So go ahead and see if this 195.5 as a modified divisor will work. So pause the video, get the new modified quotas. I'm going to go ahead and go over this. Let's see. You should get 11.3 for A. That's going to, you should get, I'll round them down in a second, 33.5 for C. Not much change there. You should get like 12.43 for D and 9.15 for E. And then when you look at all the lower quotas, this rounds down to 11, to 33, to 12, to 9, 80, bingo. And then because you may have multiple guesses and I want to make sure I know what your final answer is, I may have you write your final apportionment off to the side. The other thing that I'll probably do is I'll ask you, what modified divisor did you use? Because if you remember, there's really an infinite range, infinite number of modified divisors that you can use. So someone else might have used a different number and still gotten the answer right. So I will like to know what modified divisor you used. Okay, so there's Jefferson's. Now Webster's I am making very easy for you. You're going to do Webster's on the table. I think the hard part is to ignore everything that you've done for Jefferson's. Now, you don't want to scratch this out on your test because I need to see it. But we want to start back from the beginning, and the back from the beginning is the standard quotas. So I won't have much space to write this out, so you're going to have to remember what my little abbreviations are. Webster's method, converund, okay? Now, if you remember what I'm telling you, and you can do Webster's, go ahead and turn the video off. Do Webster's. When you're done, turn the video back on and check. All right. If you forget Webster's, I'm giving you a big hint. That's short for conventional rounding, which is the 0.5 rule. So he says, why round everybody down? Don't round everybody up. That's actually what Adams suggested. Hey, if they're 0.5 or above, you round them up. Below 0.5, they're down. The conventional rounding rule. So ignore everything that you did for Jefferson's. Go back to the standard quotas. 10.9. Oh, that's above 0.5, so that would round to 11. 15.5, yep, that would round up to 16. 32.5, that would round up to 33. 12.072, now that one would round down to 12. And 8.892, that would round to 9. Sometimes conventional rounding works. We've seen that in the notes. So we got to check, does this work? That is, did we wind up with 80 staff members apportioned? And no, it's too many. So we have to modify the divisor so that these numbers change slightly, and we basically need to lose a seat. I'm going to give you the modified divisor to use, and I'll tell you what, this one was a bear. It is really a thin margin to get this to work because some of these decimals are so close to each other. So I'm going to tell you, use the modified divisor 201.55. Just do what I tell you. So all you got to know really is, how do you use a modified divisor? Well, see, I showed it on the calculator again. What I'm telling you to do is take A's population, which is 2210 divided by 201.55. And you get 10.966. No, 965. I don't know what I was thinking. All right. So now that you've seen that, if you pause the video, get the rest of the modified divisors, and then round conventionally. So turn off the video, see if you can finish Webster's, and then check your answer. I'm going to go on. You should get 15.505 for B. Now, for C, you got to be careful here. You get 32.498. You cannot round that to 13.5 because then you'd round 32 up. As it stands, you round 32 down, and that's actually what we need. D is going to be 12.006, and E is like 8.88. So once you have the modified divisors, round by the 0.5 rule. 10.9, that goes up to 11. 15.5, that goes up to 16. 32.49, that goes down to 32. 12.06, that goes down to 12. 8.88, that goes up to 9. This does add up to 80. I will give you a working divisor. All right? So, there'll probably be this follow-up. At least maybe only 2 of the problems, not all 4 of them. Do any of these, I probably should be bad English there. Do any of the 4 apportionments violate the quota rule? Well, let's look at the 4 all together. Here's the lower quotas, upper quotas. Notice Hamilton's and Lowndes are not quite the same. Sometimes they are. But if you look at it, everyone got their upper or lower. That's the way Hamilton's and Lowndes works. They cannot violate the quota rule ever. So that's a given. They did not violate the quota rule. But sometimes Jefferson's and Webster's does. So let's look. Here's the final apportionments. You know, compare these to the upper and lower quotas. And those are all upper or lower quotas. And these are all upper or lower quotas. So there was no violation of the quota rule. You know, all hotels got either their upper or lower quota. So that's how you would explain. All right, if there was a violation, you'd say, oh, Hotel B got more than their upper quota, something like that. So I think I will stop this video and do the multiple choice on the next video.